Okay, hi everyone. Okay, so I'll be talking about a recent modernization of the Atlas software build infrastructure and also the workflow that we apply for developing code in Atlas, specifically the offline code. Brief overview. I will be briefly talking about the past infrastructure we had, the problems we found in the past infrastructure, the solutions that we then applied, and finally also the migration process itself. So in this talk, I'll actually be mentioning lots of tools. Maybe you'll find your favorite tool in there. Okay, let's start with the tools that we used in the past for version control. In the past, we used Subversion. When I talk about the past, I mean until about half a year ago, we used all these tools. So until about half a year ago, we used Subversion to do version control of our offline code. In this offline code, we had about, and we actually still have, about 2,000 packages. And when I say package, I mean a package is for Atlas is a bunch of source files that kind of belong together and that are typically built into one shared library. So we have then about roughly 2,000 shared libraries. And just to give you a feeling for the scale of the offline software code in Atlas, it's about 4 million lines of code, if I'm not mistaken. So it's quite a big project. So we had these packages, and we had a per package level access control list, basically. So the idea with the packages was that you could control really who's able to modify code that is provided in the package. We had lots of custom-made tools. For example, we had an Atlas tag collector. We used the tag collector so that the thing with the packages is also that each package has its own versioning. So we basically had 2,000 individual packages, each with their own versioning. And only when you take these 2,000 packages together, each one with a specific version, then you could build a release. And in the past, we used the Atlas tag collector custom tool basically to build these lists of tags that then allow us to, or to define this list of tags that then allow us to build offline software releases. And also to manage the access control lists for the individual packages, we built another tool, the SVN admin tool, so that users could use to add more or other colleagues to be able to modify packages. Okay, how did we do the release building in the past? So in the past, we used a tool named CMT. Basically, with this tool, you have requirements, files that allow you to define dependencies between the packages. So if you want to compile one package, you first have to make sure that the other package that this package depends on is also compiled already. So basically, this tool generates make files, and then with GNU make, you just go through the make files and build the whole project. So we had a custom build system with a bunch of dedicated machines that every night build various nightly builds of different versions or different branches, so to speak, of our offline software release. So, and then at the end of about 2015, we realized that actually our software infrastructure that we're using, if you just look at the fact that we were using Subversion, then you realize that we're probably using lots of outdated tools already. So then we realized, okay, we should maybe move to something more modern. We realized one of our main problems was that we were relying heavily on many custom tools, and especially also our workflow was very Atlas custom, basically, and there are lots of problems with this. That means that developers that come to Atlas have to first learn the Atlas tools, and they also have to learn the workflow. And when they leave Atlas, they actually can no longer apply all these custom tools and workflows. Another problem, a big problem, was also that every time you submitted a code change to our repository, you had to wait for at least for a day or sometimes more than a day until you saw how your code change affects the nightly, if it broke the nightly or if it broke some other package. Or if there were other problems. That's not just annoying for the developers, but it could also potentially actually delay releases because we build releases based on the nightly builds, or we use nightly builds to then distribute offline software releases. So we heavily relied on the developers to actually do proper checking of the code to make sure that the code that they check in really works, and we actually only saw in the nightly builds every day whether the code really works. Okay, I'll skip that example. We can come back to that if we have time later. Okay, so the solutions that we then found and later on applied. Here you might see some of the tools that you're using yourself or that you're certainly familiar with. So we moved our build configuration from the CMT tool to CMake. We used our version control system from Subversion. We moved our version control system from Subversion to Git. we established what we call the Atlas flow. The Atlas flow is a workflow that's heavily based on the GitLab flow. I'll come to that later. We established code review, so all the changes that now go into the Atlas offline software repository go through a code review, actually through a multi-stage code review using GitLab. We have continuous integration tests, so that means every time you change or you make a change to the Atlas offline software repository, we trigger integration tests, and then you see the build results from that. And also we have an offline software documentation webpage that actually documents all these tools and workflows that we now use. Okay, so the migration from CMT to CMake. So for that migration, actually, we implemented a custom migration script that took our CMT requirements files and basically converted them into CMake list files for every package. So this tool really worked for most of the packages. There were a few exceptions where we needed to manually adjust the outputted CMake list file. Also features that we migrated from CMT to CMake. We can build RPMs. We could build RPMs in the past of the entire project, and we can still build RPMs that we actually use now to also distribute the offline software. And also we can build lightweight releases. So we have some configurations of our offline software where we don't build the entire set of 2,000 packages, where we only build a subset of the 2,000 packages. One example is, for example, we have a 400 package release that is only capable of doing full detector simulation. So yeah, the packages, we kept packages so basically a package is just a directory in the entire source tree of the offline software repository, and we kept this structure of the source code with all the directories, and a package now basically in the new infrastructure is just a directory in the Git repository. So that's why we can still talk about packages, and developers that were in Atlas before, used to the concept of packages, they still know what the package that we had in the past in SVN or in Subversion is now where they can find that in Git. Yeah, so I already talked a little bit about this. So we moved our code from Subversion to Git. There are many migration scripts out there that allow you to move your Subversion repository to Git, but due to the structure of the Atlas offline software code, we couldn't actually apply any of these conversion scripts. So we had to build our own migration script. So the thing is, I was talking about moving away from custom tools. We build the custom tools to do the migration, but afterwards you don't need that custom tool anymore. And that custom tool to do the migration from Subversion to Git really, really helped us. So we didn't migrate the entire code. Basically, we only migrated pieces of the code that were in official releases and distributed releases in the last about 2 years. We dropped packages. We dropped code that was no longer used. We also dropped lots of files. We had lots of unused files in our code base that were larger than 100 kilobytes. We dropped many of them. And with this migration script, we also put copyright statements in our code. And doing all of this then actually is quite interesting. This decreased the size of our repository by more than a factor of 200. So from about 47 gigabytes in Subversion, we're now down to about 220 megabytes. I mean, that's not a completely fair comparison because we dropped lots of things and also Git does compression, but still it's quite a nice thing to see. And we also implemented a custom Git command that allows us to only check out specific packages from the Git repository. So developers, they can clone the entire repository and work on the entire code, or have the entire code there and only compile parts of the code. But if they don't have enough space on their disk or on their server, wherever they're working, they can also just check out specific packages with the custom Git Atlas command. Okay, so about the workflow a little bit. So the new workflow that we apply in Atlas is heavily based, or is basically the GitLab flow. It's officially documented on the GitLab blog. It's a very simple workflow, very simple Git workflow. The only difference, okay, so this image here is from the official GitLab workflow documentation. So basically, we have the master branch, and every time we decide to build a release, we branch off from the master, and we have a release branch, and we might have, actually, and we do have multiple release branches at the moment. And what we do in Atlas is that typically when bugs are reported, they're reported in specific releases, and often they're only reproducible in that specific release. So bugs then are typically fixed in the release branches, and we have an automated nightly sweep, or cherry pick, basically, of the bugs that are accepted or merged into the release branches. We have an automated sweep to sweep those bug fixes back into the master branch. So this is where we deviate a little bit from the official recommended GitLab flow. So we also established a multi-stage code review. Multi-stage meaning we have a level 1 shifter looking at code changes that developers request into release branch. And if the level 1 shifter says, okay, that change is okay, then it is passed on to level 2, who's a bit more of an expert, and comments and improvements are made in that code review process. Okay, that's all about the development workflow. So I mentioned before already that we have a continuous integration setup now. I mentioned that in the old setup, in the what we had until about half a year ago, one problem was that you needed to wait for a day or more sometimes to see whether your code change compiles or whether it breaks something else in the code base. So now what we have is every time a developer makes a merge request, or basically the same as a pull request in GitHub terminology, makes a merge request into release branch, this will trigger a continuous integration system, and this will run, not just compile this developer's code, but it actually run a bunch of tests just to see if reconstruction is broken and or simulations still work and so on. And typically, running this continuous integration pipeline takes about 3 to 5 hours. So that's really a huge improvement in my mind as a developer, from about 24 hours in the past as a feedback cycle now to 3 to 5 hours. And the build results are posted on the GitLab merge request page, so we'll see later what that looks like. So we still have nightly builds. So we do full builds every night for various release branches that we have. So I think currently we have about 7 different branches that we build nightly builds of. So we build off the master branch, make a nightly build, but also of the various release branches. We also build for multiple platforms. That could be Scientific Linux 6, GCC, whatever, 4.7, much newer compilers these days. So there we have 7, we've built for multiple platforms, and we have 7 different flavors that we built of the offline software code. Also, every build is then tagged in the Git repository itself. So this allows the developer really just to use Git and get the specific release or the specific version of the code that was built into a nightly. We generate RPM packages, and the binaries are installed on a network file system so that all developers can use them conveniently. So then this is still an Atlas custom tool that we're using. This is a web page that we use to visualize the build and test results per package. So I told you before, we still have this, we still have kept the idea of packages around the package in Git. Now in the new offline code, it's basically just a directory. And in this web page, you get a per package, every line here is a package, and you get a summary whether the build or a test failed in the particular package. And this is very helpful for the developers, because the raw build log output would be 15 megabytes roughly, and that would take a while to parse for a developer. And with a web page, you can just very quickly see where builds or tests failed. So this is what a discussion looks like on the merge requests these days. So you create a merge request as a developer, you change the piece of code, you fix the bug, and then automatically this will trigger a continuous integration pipeline. The continuous integration pipeline will figure out which packages you changed, and you will add people as watchers. So we have a list where you can add yourself as a watcher for specific packages, basically specific directories in the source code, and then you can watch all the merge requests that come in for your packages that you're interested in. The continuous integration also automatically adds labels, and then after a couple of hours, when the tests are done, the code is compiled and the tests are done, it will show you the test results. Then we have a code review. So typically, the reviewer comments whether he's happy or not with the code. the reviewer will then use labels to signal that he approves the merge request, whether he's happy with the merge request, and then later on we have release coordinators that then actually merge open or approved merge requests into specific releases. And then later at night, we have this automated nightly system that sweeps all accepted merge requests, all merged merge requests into the master branch. And you had comments here from the automated system whether these sweeps were successful or not. Okay, so what was important for us, so this was quite a big change for the collaboration from very old tools to newer tools or to tools that are that people use these days in software development quite commonly. So we wanted to really prepare the collaboration to the new workflow and to new tools early on. So we held a couple of tutorial sessions. Many people came to these tutorial sessions. So we held tutorials about Git the tool itself, how to use Git, and how to use Git in the workflow that I just showed you before. And also we held tutorials for the reviewers, for the code reviewers specifically, what to look for, and also how to comment on problems they find. Okay, so for these tutorials, we put up a public documentation web page, or we created a public documentation web page. So in the past, in Atlas, lots of the documentation, and actually still is, in Twiki pages, and people that have used Twiki pages might be familiar with the fact that it's quite difficult to find the information you're looking for in Twiki pages. So we decided, okay, it's maybe much better if we make just a normal web page with public information that is Google indexed. I mean, if it's somewhere on the page, you will find it with Google. So yeah, that's what we did. We built this public web page with all the tutorials and guides that I talked about in the previous slide. We put them all on this web page. It's public and Google indexed, and so in order to make it easy for developers to find the information for the new workflow. Also, this web page itself is in a Git repository, and it's actually in a continuous deployment pipeline. So every time people change something on this web page in the Git repository, it will be rebuilt and then published on the web server. Okay, so that brings me to the summary. So we moved much of our infrastructure from custom tools in the past to now well-established third-party tools, hopefully, or actually certainly solving many of the problems we saw in the past. So yeah, the tools we now use, CMake, GitLab, Git, Jenkins. Okay, I didn't mention that. We use Jenkins for the continuous integration and for the build system, basically. So Jenkins is managing our build nodes that we have to run the builds and then the tests. We established code reviews and continuous integration tests as part of the standard workflow in Atlas. We have a public documentation web page, and what was important was to have tutorials in order to prepare our collaborators early enough for that rather significant change in the workflow. Okay, thank you.
I have one question concerning your CMT to CMake migration.
Yeah.
So CMT was not only a build tool, but also provided a runtime environment. You could set up, I mean, CMT, I don't remember exactly, it was CMT run or something. It put you together the LD library path, the Python path that you needed to have. CMake would not provide you this, I understand.
For the environment itself.
Did you have to do something special for that?
Let me think. Yeah, I'm not an expert on this, on how we used CMT in the past specifically. So we certainly used it to generate the make files, to figure out the dependencies between the packages. I don't know if we used CMT to actually define it on our environment. Yeah, people are nodding. Okay, so yeah. And so now what has changed for the developer? Well, we still had a command in Atlas that we run to set up the environment, and which is basically for the developer. We still use the same command. Maybe options are a little bit different now, and that spits out the environment. So behind the scenes, things have changed. And sorry, we can talk afterwards, and I can try to find who works on that and how we changed that.
So somebody with working with CMS, if I kind of compare the cards, a lot of the pieces look familiar. One thing CMS hasn't done is replace or hasn't started or decided if they want to start is replacing the legacy build tool. Could you provide a little more comments of how the CMake transition went? What were the highlights? What were the lowlights? Is anything left over that people still get angry and upset about? And Gordon just smiled, so maybe there's still a couple things to kind of just, I don't know, expand for a minute or so.
Right. So specifically about the CMake migration, I can give you any details, but we can talk afterwards, and I can try to figure them out for you. About the build system itself, it doesn't work anymore. Okay, so what is certainly true is, we were inspired a lot by what CMS did, and what really helped us was that CMS also has a public page with documentation on how the system works for them. And and we based our new workflow on our new system, I wouldn't say heavily, but we were really inspired by what CMS did. About the build itself, but Jenkins, maybe worth mentioning is that, so we were at a point where we could either then choose to use the GitLab continuous integration facilities that GitLab provides, but we figured out that actually with Jenkins, we're much more flexible than with what GitLab provides, because our setup is a bit more complicated than the one that you could do out of the box with GitLab itself. So that's why we decided to use Jenkins, for example. And I'm not sure if CMS is using Jenkins or not. Okay. Does that answer your question? Okay.
Come back to you later.
Okay.
So you said you sweep the bug fixes in the release branch to master. How about the other release branches? Do you sweep all over the place or just into master?
Yes. So at the moment, very good question. At the moment, we sweep only to master. The problem is if you then start sweeping from one release branch to the other, then at some point you can end up with a cyclic sweeping between release branches. So then it's the responsibility of the developer, basically, and the release coordinators to make sure if a bug is fixed in this release, to figure out whether this bug actually also affects another release and needs to be fixed somewhere else. You can always manually sweep or cherry pick changes from one release branch to the other.